Hi everyone. I'm going to be staying home today because I'm unwell, sick. So I want to go over some of this because I noticed in section 2.5, well, things are getting real. To say it in the simplest way, is that it's getting to be a little bit more difficult. And these formulas, I recommend against just simply memorizing them. I strongly suggest that you learn them. You can memorize them fine. So I want to just go through the process and give you some strategies to to learn them versus memorizing. So this is one of the formulas that 2.5 goes over. So final velocity is equal to initial velocity plus acceleration times time. You can think about the units. So if you ever forget about the formula, if you ever forget how to do it, think about the units and think about how what happens is the initial velocity. Of course, you want to add the velocity after the acceleration occurs over a certain period of time. So there's the acceleration, here's the period of time. What's going to happen here is these seconds are going to cancel. And that's why I did the dimensional analysis lesson with you, so you could understand this a little better. And we can cancel that square because there are 2 seconds in the bottom. And now we have a velocity, the added velocity after the acceleration occurred. So if we add the initial velocity and let's say the difference in velocity, and I have this right down here, I tried to indicate it in a clearer way. So we have the initial velocity, and if you ever see a delta sign, it means change. So plus the change velocity after acceleration, then we get the final velocity. And that makes intuitive sense if you go through the process of canceling out units. And if we look at this one, acceleration is the difference in the velocity is the final and the initial divided by time. Again, I strongly suggest you think about it in units and just try to get the units canceled to find what is being sought, I guess, what you're looking for. We're trying to get to velocity. And let me scroll back up here. And if we look at the formula for acceleration to find the acceleration, if we're dividing it by time, then we're going to get the units consistent because we're dividing two parameters here, and the denominator for the denominator, if that makes any sense, is 1. And when you divide fractions, remember this from whenever you're 6th grade or whenever, when you divide fractions, you multiply by the reciprocal. So the next move here is we can just get rid of this, and we're going to multiply by 1 over 1 over seconds. And when we multiply, so we're going to multiply meters times 1, and then we're going to multiply seconds times seconds. And remember this from 7th or 8th grade. Then when you multiply exponents, I'm trying to draw this and it's not coming out the way I want it to. You just add them, okay? So we wind up with meters per second squared. And here's what you wind up with. So these equations, both sides of the equation, are going to be equivalent. So again, go from the actual formula and break it down into units. And if you forget the formula, think about the units and make sure you make the units on both sides to be equal. And maybe the actual formula will come back to your memory, or you can work through it from beginning to end. And remember, you're starting at the beginning and you're working your way towards the end by using this process of canceling out units and trying to get to the beginning, if that makes any sense. Well, I don't like the way I said that, so let me just show you. So if let's say you know you have to find the acceleration, but you forgot how to do this part, which this one's pretty easy. I'm going to show you a harder one in the next video. But you can think, okay, so I want to get to meters per second squared, like I told you in this step. And then you can think, all right, that makes sense. Velocity divided by time, that'll get me to meters per second squared.